our 2019 paper, we will be going through a certain number of questions. Okay. First question we're going through is, let me look on my document to see where I listed the questions that we're going through. Okay. Questions 1 to 3 at first. So let's go down. So the first one, we're given a map. And for this map we're given, it is actually an extract map at a scale of 1 to 50,000. Okay. Now question 1 asks us this about the map. What is the direction of the trigonometrical station at Shotover? 72, 9, 46, 3. That is the trig station at Shotover. And then we have Robertson's Halt at 71, 1, 47, 1. You've done grid references already, Alex? Not yet. Okay, so there are many ways we can find a place or locate a place on a map or on the earth, the surface of the earth. And one of the ways we can find a place is by using grid references. You probably learned a little about latitude, using latitude and longitude as one of the ways to find or locate places on the earth. Or you may also have learned about using compass direction to actually find places on the earth. Okay? Now, the thing is, for grid references, it means that the map or map extract that is used has squares on it. There are lines that are running from north to south and lines that are running from west to east. We say west to east because just like how we write in our exercise book or notebook, we write from the left margin going straight across to the right margin. That is how the lines run across the map. Okay, from left to right or west to east. Now, those lines that are running across horizontally, just as you see me moving my cursor across those lines right there, we call them northing lines. Northing, because they are actually increasing in number as we move up to the north. You notice that, Alex?
Yes, yes.
The first northing number we have is what? Look at the first horizontal line. What's the number you see on the first horizontal line? You can look at the left side, the west side, left margin, or the right margin. You'll see the numbers for the horizontal line right beside the horizontal line. And by horizontal, we mean going across.
45, miss.
45, very good. And the next one is, where my cursor is?
46.
Next one?
47.
Good. So what we're saying, Alex, is that northing lines always increase from the south or the bottom going up to the top, the north. Okay, and that is what we see on this map extract. Now, the other lines that are on this, and it is actually northing is a grid line that is increasing northward. Then we have the vertical lines going down on the map or the map extract, Alex. And the vertical lines coming from up above to down below, running from north down to south. Those lines are called eastings. You know why we call them eastings, Alex? Because each of these vertical lines, starting from your left margin in your notebook or from the westernmost side of your map, these vertical lines, as they go across the map extract, moving towards the east, they are increasing towards the east. Look at the numbers. If you look at the top margin and the bottommost margin, you will see the number. So what's the first easting line number that you see, Alex? At the top margin or the bottom margin, look to the left where we start. From the left moving to the right. What's the first number you see right where my cursor is for the first easting line or vertical line? What's the number you see here? Can you see clearly? Or I need to make my thing a little bigger?
I can see it's 70.
Very good, excellent, 70. And you notice, Alex, it's increasing. The next one is 71 as we move to the east, 72 as we move more eastward, 73. And then if there are more places on the map, it would continue increasing. So I want you to remember that easting lines are vertical. They increase from west to east, from left to right. Northern lines are horizontal and they increase from south to north. Okay, now that we have established that, I have to expand my map extract a little bit so that we can see the names of places on this map, because we have two places looking for. Right now, we are looking for a trig station, trigonomical station, trig for short. We're looking for a trig station that is found at a place called the Shotover. When we find that, we're going to circle it. I'm going to circle it with a colored, using annotation, I'm going to circle it. Let's find it first of all. So did you find Shotover? It is at 72. So let's go 72, because the next thing I need to tell you, Alex, is this. When we are reading our grid lines, we can read it as 4-figure grid reference or as 6-figure grid reference. So what really happens, Alex, is that the geographers put the two numbers together. So you have your easting line, you have your northing line, you know, notice it's a double-digit number you have for each of them. So for our easting lines, that's the ones we always read first. The ones that are vertical and moving across from left to right, west to east, those are the ones we read first. So just imagine you're going in a building, Alex, and you have to go across the floor before you can reach the stairs to go up. You have to go across the stairs. So you're going across the easting lines. Across, let me go again. Across the easting lines, you're reading them across. So you must read the easting lines first. And then when you're done, you will go and read the northing lines, which increase upward. Okay, good. So it means that for 4-figure grid reference, we would need two numbers for the eastings, 2 numbers for the northings. But there's 4-figure grid references give general location of places, Alex. General location of places. So within this old box here, so it is given a location of this place right here. All right. What we would have, and I'm going to give you an example of the 4-figure before I deal with this. So here, I'm going to find a place. Let's look at this place. This is a map that is kind of obscure, meaning the things are not so clear because it is in black and white. So we have St. Margaret's Bay right here. You can see that clearly, Alex, right? Where St. Margaret's Bay is located, it is in a grid box. It's just that the grid box is a bit cut off. The grid box looks like it would have extended some more to be a full square, all right? But don't mind that. Let's look at it now. To find the grid box in which St. Margaret's Bay is, we need to read the number on the eastern line first, and then the number on the northern line. We must look for the eastern line that starts the box in which St. Margaret's Bay is located. We must look for the easting line that starts the box in which the place is located. And the place right here, I'm giving an example of it, St. Margaret's Bay. Can you tell me the number for the easting line that starts this box, Alex? Remember, we're moving from left going over to right, you know. So we're talking about the easting line that you buck up when you reach the box that has St. Margaret's Bay. Can you tell me which number is on that line, that easting line that starts the box with St. Margaret's Bay, Alex?
It's 71.
Excellent. It is 71 right here. So it starts the box. So it is 71 easting. You read first. When you're done with the 71, you write down the 71, Alex. Then I'll take out my annotation tool right now. When you write down, so we say that it is 71 for the grid reference. It's a bit ticklish to use this thing, you know, but I'm trying. So it's 71, and that's the easting. Now we have to find the northing. which northern line starts the box that has St. Margaret's Bay in it. And remember, you're coming from down the bottom, down south, you're coming up towards the box with St. Margaret's Bay. Can you tell me the number that starts the box? The number northern line that starts the box for St. Margaret's Bay? The box for St. Margaret's 47. Excellent, Alex. You're getting the hang of it. For somebody who just do good reference for the first time, you're really getting the hang. So we have 71 right here, and we have 47 right here. So we're gonna write down the 47 right here. And that would be or 4-figure grid reference that tells St. Margaret's Bay is. So it's in that box started by 71 easting and 47 northern. But sometimes, you know what happened, Alex? Sometimes they want to find the precise, the exact spot where a place is located. If we need to find the exact place where a place is located, it means that we have to go a little further. We have to use 6 grid references. So we use the eastern line that starts the box. Then we have to find the exact line within, eastern line within that crosses through that place. So that is going to be a number there for us. And then we have the northern line. And then we have, so 47 is the northern line again. And then within the northern, we have another number. How do we find that number now? The first thing we go to is the eastern line. And so for the eastern line, it's all of this line coming down, but it's just this part that formed the box with St. Margaret's Bay. You know what we're gonna do to get the 3rd digit right here? We have to divide this eastern line into 10 equal parts. First thing with Alex, you find the halfway point. Half of, if you have 10 little points, it means halfway where would be 5 is somewhere about here. Once you have found that, then you're going to begin to divide it into the 5 equal parts on both sides. So you get 10 equal parts here. So suppose we wanted to find Robertson's Halt is right here. So, all right. So we want to find where Robertson's Halt. All right, we are looking at this point right here along the coastline. All right, where the river apparently goes out to the sea. All right. So here now, what we are doing is we need to find which number would fall here. We have divided it in half at the 5th point. So we're going to divide this equally going up in 5. That is maybe 1, another 1, 2, another 1, 3, another 1, 4, and this one is kind of not so clear, but if you can see the purple lines that I have, Alex, those are the markers. Over here, we'll mark it off again. That is 6, 7, trying to get it straight. 8, I kind of do a little thing there. 9, and then 10 would be the one up here, but you would stretch it out a lot more. So when we have those lines, now we're going to see where this lines up. See the spot right here? We are going to see which one it lines up with right here. So when we look at this, we had the first point of the line was where we have 47, 0, and then 47, 1, and then 47, 2. So right here is 47, 2. But this one you're looking at right here is for the northern. All right, so we'll have the 2 on that. First, we would look for the eastern line, but because I dealt with this line first. All right, so here we have, sorry, let me do a correction here. Sorry, there. We're on the eastern line. So the number we find that is 2 right here, we're actually going to put it beside the 71. Sorry about that, Alex. Because we have divided this 71 eastern line and we are saying which part of it this place here lines up with. So that is 2. We had 0 where the line starts, where it intersects with 47, northern. We have 1 right here, we have 2 right here. And 2 is what lines up with this feature right here, this geographical feature. Next thing we're going to know, you see this northern line that is 47 coming across here. So now I'm going to use a brighter color like red. Now this northern line, we are going to divide up that northern line into 10 again. So we're going to go about halfway. I'm estimating that halfway is about here, Alex. So you see me put my line right here for 5. That is the halfway mark. Then I'm going to divide this. This is the 0 point. Then I have about probably 1 right here. I have about 2 right here. It's kind of very wide, so I should have made it wider. Let me make that a little wider. All right, so it's realistic. So this is about 1. This is about 2. This is about 3. This is about 4. Then we get to 5 right there. Then you're going to 6, 7, 8, 9. Go a little further for us. Okay. I will know that would be coming back to the 0 point out there. So we have 10 equal mark-offs there, Alex. Now remember the place up here, so we were looking at. We see where it lined up here with number 2. And then we see where it lines up here, right? Going right down here. It's halfway between this. If it's halfway between, remember we're counting from the first one, 0, 1, 2, 3. So it is between 3 and 4. We don't reach 4 yet, so we call it 3. And that number 3, we're going to put right beside the north. So let me just recap that quickly. For the grid references, we have to divide the easting into 10 equal parts when we're finding the exact spot of a place. After we do the 4-figure grid reference, we find the easting line already. We put it beside the northern line right here. Easting, northern. All right, there we go. And then we have right here where we have the 2 that was along the eastern line where we marked off the 10 equal points. And then we found that coming up from here, from the boundary here, we have 1, we have 2. Okay, so that is how we got the 2 here. So it is on the second part of that 71 eastern line. So we put the 2 there. Then we come to the northern line 47, mark off 10 equal points. And then we start from the center right here, the boundary right here of the eastern line and the 47 northern line, and we divide. After we divide it by into equal parts, we're going to count off because we marked off where the place lines up with, and then we count off and we actually get 1, 2, 3. We don't reach 4 yet, pathway, so we still call it 3, and we write our 3 beside the 47. So that's how we would have gotten that. Now for the question, Alex. It says that Shatova, the trigonometrical station, is located at Shatova. It means there we have to know what a trig station looks like. Do you know what a trig station looks like, Alex? You did conventional symbols and maps in map reading with your teacher?
No, miss, I can't remember what I.
Can't remember that. Okay, that is one of the early things we learn when we're dealing with maps. After we learn about the types of maps, we learn about the 5 main elements on the map, which are the title, the border, the compass direction placed on it, the legend or key, and the scale. Those are the 5 things. Then we come to all the conventional symbols that are used on maps. And by the term conventional symbols, we simply mean the main types of symbols that are used for the main or the most usual, the most common geographical features that are seen on the land. So we know that rivers are found on the land. So it is good when they have one single symbol to represent rivers on any map at all. When you look in any atlas, it is the same symbol used for river in any country, in any atlas. All right? On any map, it will be a blue curvy line for the river, no matter which map you're looking at or which atlas. All right. So too, the trigonometrical station is actually a monument or a feature, a man-made feature that is built on the top of mountains or hills. And usually it's more so the mountains, because these signify or mark the highest point of a mountain. Okay, so where we have Blue Mountains in Jamaica as the highest mountain in Jamaica, there is a trig station up there. It is a On the map, you will see a triangle. The triangle is usually black. Sometimes the triangle is transparent, like this one. So right here, if you look where my cursor, my pencil is moving, I am actually circling the trig station that is found at Shatova, right here. The trig station that is found at Shatova right here. That is the one they're talking about at 72,946.3. The 46 here, and it gone up a little bit. 46 is the line that starts this box right here. This box that has in the trig station at Shatova. Let me boundary off the, put the boundary for this box, this grid box that has in Shatova and the trig station. So here we have our 46 grid line. Here we have our 72 grid line that start the box, 72 eastern grid line that start the box, 46 northern grid line that start the box down here. And that is why we have 72.9, because it is all the way over to the corner. So they've estimated that this is 9, around this side is 9, okay? The specific area, 72.9 and 46. And when we line up this, coming across, if you were to use a ruler coming across, it's almost about 3 markers, okay? All right, 1, 2, 3, not so much. Let me erase one of these. There's one in the middle of this. All right, so we have 3 markers there. Now, the next place we need to find, because 2 places they always give us, 2 places they give us. Read the question first again, Alex. So finding the trig station from at Shatova from Robinson's Halt, right? At 71,
Yes,
so 71 east line, yes. What are we finding? The direction? Tell me again what we're finding there, Alex. I don't have the question in front of me, I have the diagram in front of me. Because I'm annotating, I don't want to move it. So remind me of the question. Just read it for me, Alex. Question 1, you have that nearby? Have it nearby? Or let me see if I can go down and then come back up. I have to take off annotation and then come back to annotation. I'll do that. All right. So here we had the question. What is the direction? Yeah, direction is what we're looking for, Alex. Of the station, trig station at Shatova from Robertson's Halt. All right, let's go find Robertson's Halt, Alex. All right. So Robertson's Halt is right here. I'm going to circle it. I'm going to bring up annotation again, and I'm actually going to circle it. All right, here we go. We found Robertson's Halt earlier. It was nearby to St. Margaret's Bay. This is really where it is, right here. Right? See the halt right here. Let me put the halt in a different color. Right here. See this figure right here, so? Yes, this thing that come right here, so that's the halt, okay? So now that we have found Robertson's Halt, the question says, find the direction of the trig station at Shatova from Robertson's Halt. Let me tell you a little rule, Alex. Whenever you're finding the direction of places, the place that says from that place, just imagine that that is where you are. That is the fixed point. It's not moving. That is where you are. You are at Robertson's Halt. So when you are putting your compass on that point, this is where you would have drawn your north-south line through. Always draw your north-south line through the place that comes after the word from. Understand that, Alex? Want me to repeat it?
yes, sir.
All right. So I'm saying whenever we get to find the direction of a place from another place, it means that the place that comes after the word from is the fixed point. That's the place where we can imagine ourselves standing. So that place is actually Robertson's Halt in this case. So we draw our north-south line through that place. which is Robertson's Halt. Once we have done that, it's a compass we're actually drawing in now. Now we need to connect the trig station at Shotover to Robertson's Halt that is lined up already on the north-south line. So see my north-south line here, Alex, and now the midpoint of that, I am going to come down, and I don't have a ruler, so I have to trust my sketching with my free hand. Let me try and get this annotation bar going. Okay, here we go. So my line should go somewhere across here. I'm not using a ruler, so I'm just estimating. And it's gonna go through, the trig station at Shotover. All right? You see me drawing up the lines there, Alex? You're seeing it on the screen, right?
Yes, ma'am.
Are you seeing it?
Yes, ma'am.
Good. Now, this compass here that I have, you learn about 4-point compass, right? Where you have the north up here, the south down here, the west over here, the east over here. So we would have our line going from west to east, right over here. West on this side, east on this side. All right, and north up here and south down here. Now, we are looking at it from this center point, and I really should have carried up my west to east line a little further up here. Let me do that. Right at the central point that I joined the two places. So when we come down, we have this line going between which 2 points of the compass, Alex? Which 2 points of the compass does this line fall between? Tell me the 2 points of the compass. See one at the point here? See another point down here? What are those points? You know what I mean by points? The cardinal points, the compass points I'm talking about. What are the 2 compass points? That are line joining Robertson's Halt. See the line here joining Robertson's Halt and the trig station at Shotover? Between which 2 compass points? East and south, yes, or south and east. Now, you know that when you are doing the compass and you are putting the intermediate line that falls between each of these, you put the 2 compass points together. So if we were to, this is a 4-point compass because north is 1, east is 1, south is 1, west is 1. But you can have an 8-point compass when you divide it up. So if we were to divide it up, we would go like this. We would go diagonally between each point. I'm trying to draw the line as straight as I can. Sorry about that. It would have come over some more. Let me get it a little better. Okay. So here we would have it going up. Okay. One would go right through there. And then we would have another one coming this way, going the other diagonal direction between the other set of compass points, like that, to give us an 8-point compass. All right. Sorry, my annotation bar is sticking on me. Okay, I'll get it. Yeah. And then we have the one down here. All right. Now, when we're naming them, we always start at the north. If this is north, then it means when we come halfway in between 2 points, north and east, we're going to use the 2 of them, put them together to name this one. And north and south are the 2 main points of any compass. So if it is at the top, if the point is on the top half of the compass here, the first letter must be north, right here. The first letter is going to be north N right here. If it's on the bottom half of the compass down south, then the first letter that makes this compass point in between will be south, for S for south, and S for south here. All right, so let's put that together now. So we have north because of N right here, north right here, and we have east right here, so we're going to write northeast. Northeast is the point that comes between the north point and the east point. Okay, when we come here, we have what? Tell me the two that we're gonna have right here. It's coming in between these two. So how we're gonna write it? What we call the point in between here, halfway in between east and south.
Southeast, miss.
Excellent. Southeast. Let me put the S and the E for that. When we come around here, the point that comes between west and south, what do we call that?
Southwest.
Southwest. Excellent. When we come up here, what do we call this point between west and north?
Northwest.
Northwest. Excellent. You're getting it, Alex. All right. So now that we have that, what we really wanted to look at was the point that joined to the north-south line, that joined Robertson Halt here to the trick station at Shotover. You see where this line is going? Which line is it nearest to? In other words, which compass point is that line joining Robertson's Halt and Shotover closest to? Which one of the 8 points of the compass it is closest to? Is it north, northeast, east, southeast, south, southwest, or west or northwest? Which one of those compass points is it closest to? We're looking at the pink line now. The pink line joining Robertson's Halt to Shotover. Which one of those 8 compass points is it closest to, Alex? I know it's hard to see the green so clear, but remember we name them out, Alex. So we know in between east and south, what point is that, Alex?
Southeast.
Southeast. Does it look like it is closer to southeast than to any other point on this particular compass? Yes. And so the direction would be southeast. That is how we get the answer, Alex. Okay, good. I hope you understand that. And that is how we work out with references. Don't mind the annotation, it moves with the screen, okay? So the answer would be B right here, Alex. B is the answer. All right, so I hope you saw how we got B. Okay, now we move to question 2. I'm gonna have to do some erasing of the annotation.